Hi, everyone. Thank you so much for attending today's webinar, Applying Graph to Customer 360 to Increase Top-Line Revenue. Before we get started, I wanted to just go over a few items with all of you. There will be time at the end of the webinar for a Q&A. So if you have any questions, please leave them in the Q&A box or in the chat at the bottom of the screen, and we'll be happy to address them. We are recording today's session, and I'll be sending up a follow email as well. If you have any questions or issues, please feel free to reach out to Expero Internal with any questions. We hope that you enjoyed today's presentation hosted by Expero and TigerGraph. And with that, I'll go ahead and turn this over to Michael Shaler from TigerGraph.
Thank you, Laura. It's a pleasure to be here today, and I wanted to say thank you to everyone. We're going to be walking through the notion of Customer 360. We need to go back, Scott. Sorry. Okay. What I want to do is introduce everyone to the webinar and talk about kind of what we're going to be talking about today. So the Customer 360 focus is going to be tying together graph analytics, machine learning, and humans. And what we want to focus on are especially, in the context of healthcare, why do we need to change and why now? We're then going to talk about the art of the possible, and Scott's going to show us what this might look like. And then we're going to transition to Graham, and he's going to give us an overview of a combination of machine learning and graph and how we can do entity resolution and other elements of Customer 360 to increase accuracy and drive revenue throughout. Finally, we're going to close with Victor Lee, who's going to talk about graph-enabled real-time machine learning and the outcomes that can come with that, increasing accuracy through algorithms for better outcomes. So with that, I'm going to dig into the next set of points here. One of the things that's interesting is I'm actually surprised that Gartner is actually digging into data and analytics and really doubling down on their focus on graph in ways that is a wonderful and happy surprise for all of us. Obviously, in terms of accelerating change, we know about AI and composable data and analytics, how data fabric is so important. And when we go from the big to the small and wide data, but then we also are talking about how to operationalize this business value in terms of cross organization operations, engineering decision, data analytics is a core business function. That's moving things into the core in ways that wasn't before. And then, of course, what we love to see is when we talk about distributed systems and distributed outcomes, how graph relates everything. Connected data is going to be the key to a lot of what we're talking about. And then we're also seeing in the same breath the rise of the augmented customer. How customers are going to have new insights, and we're going to have new insights into them because of how we connect everything. And then the last point is, data analytics at the edge is when we really start to see differences from an IoT perspective, but also in terms of customer interactions and customer experiences. So, today we're going to really focus on graph and machine learning and how that transforms the data and analytics that support the augmented consumer and Customer 360. So next slide, please. When we think about kind of what different industries and different engagements involve, we're seeing kind of a set of business capabilities and technology foundations that McKinsey has highlighted in terms of what the models for analytics need to be in terms of graph and streaming and visualization and machine learning and artificial intelligence. So you can see at the top, on the upper left, there's consumer components, provider components, and internal components. What's interesting to me is that most of that data comes from outside the enterprise. The digital health ecosystem is so externally leveraged that's where the bringing that into understanding external data sources and external experiences, bringing that into understand how that fits into a member journey is very, very powerful. And so, still internal components are very, very important. We have lots of analytics and data privacy considerations, and then all the back office automation that we can make happen around claims and other entry points is also powerful. And then from a technology perspective, complementing those aspirational business values, we also have to have, we need to have the core components for a vibrant digital health ecosystem. That means consumer-facing components, provider components, and internal components. And so you think about how we need to stitch together all the APIs, all the digital front ends, all the surface integration, and then how to have a flexible and secure data layer with the microservice landscape, and then automation at scale. The summary is we're looking at how to engage customers and members in new ways that have not been done before, and there needs to be new foundations from a business value perspective, but also from a technology foundation perspective. So McKinsey's insights here really kind of point us toward graph and streaming and visualization and machine learning. Next slide, please. So back to Gartner for a second. One of the things that Gartner has highlighted, and this all matters a lot when it comes to customer 360 use cases, is the different kinds of analytics we can do with graph, and then that feeds machine learning that can actually amplify the insights that come from graph. So there's obviously pathfinding. How do you find optimal paths? There's community. How do you identify group clusters or partitions? Who is the most influential set of customers? What changes customer behavior? How can we leverage what we know about other members' journeys? And centricity identifies the most important nodes, which is related to community, right? And then finally, as we work our way around, we look at similarity. Do two members have similar outcomes, even if they're very, very much, they have a lot of similarity? But then we have link prediction, and how the likelihood of nodes forming or breaking connections is very powerful. And then we have connectivity, determining the connectivity strengths and weaknesses that are part of that network of influences that impact a consumer experience. And I think what my takeaway from this is that Gartner has really kind of helped us understand the power of graph analytics that can define relationships and then operationalize it in ways that goes beyond what we've seen in the past. Very, very powerful story here. Next slide, please. We all know that between kind of making money, protecting money, and saving money, that the risk of having customer churn and how that differs from a B2B perspective or B2C perspective, and then voluntary and involuntary churn, hence 360-degree view of the customer can become. And what that means also is that we're seeing tremendous upheaval, especially in the age of COVID, where the risk of losing a customer for life is so great because of things that are under our control but are not managed well. And so what that means is that we can drive better customer satisfaction, and then we can have a single view of cardholders and customers and members in ways that we have not been able to do before. Summary is, there's billions at risk and there's billions to be won. And the companies who do this well are going to be the ones who are going to come out on top after we come out of all this. Next slide, please. So if you look at financial services for a second, you can see that that this survey highlights, how do you remove friction and how do you use big data and AI? That's top of mind for financial institutions and suppliers. And what we're seeing though is it's not just a matter of knowing your customer. KYC is not enough. It needs to be also, especially in the B2B context, needs to be know your customer's customer as well. That's customer 360 with graph and machine learning. This is a top priority. Look at the first three elements there, that are highlighted in red. How do you have integrated multi-channel delivery? Well, you need to have a connected view of the customer and their customers. And so the summary is that we have extreme focus in both healthcare and life sciences as much as we do in financial services and other industries. So we're really excited to highlight how we can change the understanding of what Customer 360 really is with graph and machine learning. Next slide, please. Now, as we start to think about all the data sources, all the events, all of the connections, all the APIs we need to integrate with, that can feel overwhelming. But when we start to think about what we can do to build a real-time human 360 data hub, this is how we can actually integrate all the transactions, all the interactions, all the experiences into a unified view, because now we're connecting the dots in the graph. We can leverage existing investments. This is an evolutionary approach, not revolutionary. We're not asking anybody to throw anything away. We're asking to make the answers much, much better. And so that means that we can find new relationships. We can analyze time series and geospatial data. We can expand and grow our schema in real time. But the net is the business benefits of this approach can uniquely improve the outcomes, increase satisfaction, lower costs, and reduce risk. Next slide, please. So in terms of, again, taking this theme of know your customer's customer in the B2B experiences, know your customer in the B2C experience, there's 7 key sources of pain here. One is, we need to understand the customer journey. And that is not just, a lookup in a table. That means we have to understand where they have experienced things online, in store, in the facility. We need to understand all those experiences of their customer journey. We need to understand further if, where have they been and where are they going, but we need to understand what are their hidden complaints. It takes an extraordinary customer to highlight that they have been through a difficult experience, and silent departures are deadly to businesses. We need to avoid churn. Why have customers left? Why did they quit their product or experience? How do we amplify their loyalty? Especially in the age of COVID, we need to do that in new and different ways than we have thus far. We also need to have positive interventions. If we have data-driven campaigns and really personalized outreaches to say, come back, we have something new and better for you, and we know based on your experience that you've wanted this for some time, and we're really excited to share that with you. So having those kind of interventions and those moments, so that enables quite naturally how we can cross-sell new products and services, because we've brought them back in and now we have something new to share. And then that means that they can, based on that experience, they can actually go out and tell the world about it on our behalf. And that can be a positive or a negative thing. What we're looking for, though, is ensuring that if we were driving the customer journey well, that we're going to be able to get customers to speak on behalf of the business in a way that is very, very powerful. So those are the pain items, and we can turn those into common relationships and connected data analytics. We need to have not just a customer 360, we also need a product 360. We need to understand all the interactions that goes products and relationships around that. What stitches together these experiences between products, services, and customers is very, very powerful. We have a long history of being able to track all the transactions, but we don't have them in context necessarily. We need to know not just amounts and locations or types of goods or stores and amounts, but we also need to know what are the connections, what are the paths that are the fast path to success with a customer. We need to know who are the actors, who do they come in contact with, how do what about have we equipped call centers with all the resources they need to have a successful discussion with the customer. We need to understand the geospatial considerations of the customer 360. What are the physical locations? What are the corporate entities? Where do these things happen and how? And then we also need to understand, in the world where, we have all the devices that we could ever ask for, it seems, but we also need to understand how do customers experience across their device network, their own personal network. And, we need to know about MAC addresses, IP addresses, and we need to know everything about all of the other network considerations of those devices. And then finally, we need to, look at carefully the application of the good and the bad and the ugly on social media. Summary is that being able to bring together all of these data sources, all these experiences, all across space and time, and with their logical and physical connections, is a very, very powerful requirement for us to do customer 360 in a very, very different way. Next slide. Now, in terms of use cases, these are powerful, but where we start with, in the case of customer 360 is, entity resolution. who is my customer? What makes them unique? How do I identify them across multiple email addresses, multiple phone numbers, and multiple persona? I'm a different person at work than I am at home in terms of my interaction with vendors, with products and services in my life. So we need to understand the customer journey. We need to do churn avoidance in ways that we've never been able to do churn avoidance. We can track these things over time in ways that we couldn't before. And we understand the pathways that define that process. We need to do segmentation and recommendations in a very different way. Graph databases make a powerful foundation for recommendation engines. And that enables us to cross-sell, upsell, and then have the best next conversation, avoid hidden complaints. So what are the solution needs that drive these business cases? We need to be able, be flexible in the cloud. I mean, that just makes everything more connected, more agile, and more scalable, quite frankly. We need to be able to visualize it. We need to have understandable, explainable AI. We need to understand the dependencies of the networking. And we also need to ensure we have the right data science foundations and the right machine learning operations. And Graham's going to talk more about that shortly. We need to map the networks that they participate in. We need to have real-time data from IoT systems. And then obviously everything has to be available continuously. From a machine learning and analytics perspective, we have patterns. We need to do what ifs on digital twin experiences. We need to have predictive and analytics. Scoring and risk is necessary, but not sufficient. We need to have audit and compliance. And then we need to have decision trees that make sense. Summary here is, building this all together, from a customer 360 perspective, it drives the outcomes that have the highest business value you could ask for from a customer engagement. Next slide, please. So why change now? Okay, so we have a lot of pressure from the consumer side. They have digital experiences. They have a member customer product 360. We have demographics that are shifting. We have a legislative and regulatory environment that's changing. We have cost and price pressure. We're changing, we're seeing medical procedures transformed in this new world we're living in. There are changes in outcomes that are completely different. Cloud is changing everything as well. Everything is getting connected in the cloud. It gives us agility, it's elastic, and it's highly available. In terms of the advanced analytics and visualization, we really are seeing changes there. Market pressures are occurring. Competition's never been higher. We have medtech startups, we have technology giants. Everyone is going to become a bank over time. And they're going to get into healthcare. We see new diseases and reaction time. I mean, in the age of COVID, wow. And then in terms of regulatory and partner pressure, no company is an island anymore. We have real-time health records in terms of HL7, and we have the portability of data from an e-health perspective. And we have telehealth obviously at the forefront in 2021 as well. So we need to change now. So I'm going to hand it over to Scott. He's going to talk about what the art of the possible here is. And I'm really excited to see kind of how we show what can be done with Customer 360 and how we optimize those experiences. Over to you, Scott, please.
Thanks, Michael. Well, what we'd like to do now is actually, let's put a face on this, right? So one of the things that I'm going to do here in this section is talk a little bit now. Michael set the table, and unfortunately, Amazon has thrown us the gauntlet, right? So regardless of what market you're in, people now have that in the back of their mind, regardless of the industry. So if you're in telco, or you're in healthcare, or you're in financial services, whatever it is, people expect that immediate, complete understanding of my product, my journey, who am I, and what do I want to do. And what we see in this is typically the tree of pain. And where we're going now is when we look at the sort of the applications, whether you're one of these silos, if your business wants to focus on any of these, you see the dotted lines over on the right, meaning they could be connected, they might be in a silo, but ultimately somebody who writes the check, and you may be in this meeting, right? There are things that our business needs. We need to cut costs, drive revenue, and mitigate our risk. Those never change, regardless of where we are in the world and how we do that. But what we do over on the right, now we see this sort of intertwinement for Customer 360. There's a very fine line as it moves into a positive or negative experience, it turns into churn, it could be risk, and then ultimately down to compliance and audit. And the takeaway now is that these multiple use cases are something that graph, machine learning, and now the visualization can really sort of up our game. And that's what we'll look at. Now, where you sit in the organization, you could be an executive at the top, you could be a line of business or customer service rep in the middle, or you could be out on the front line. You could be making the recommendation or talking to customers, right? Or as we see this now in the investigation or analytics groups, which is now a huge burden for folks that are starting to do things at scale. Why, where, when did this customer leave us? How do we change it? How do we know when it even happened? How can we alert ourselves so that it doesn't happen again or intervene early? That's really what this whole stack is about. The second thing is that TigerGraph and Expero have put together now toolkits and solutions that allow us to go in and solve this entire problem, not just more at a data layer, not just at the machine learning layer, but at a solution layer. And that's really sort of where we get the biggest impact on this is, again, as Michael mentioned, bolting on. We're not talking about ripping out what you have today. We're talking about making it better. And for you, it may be the top section in blue, but ultimately you need a graph to power behind it. It may be you in orange or the whole stack, right? That's our goal. Now, one of the things that Victor and Graham are going to point out is that this combination of using a graph, using this combined connected data, it's 10 to 11% better when you take this baseline, which is what most people are doing today, and you integrate now graph. How do I up the accuracy? How do I increase the connected outcomes, those kinds of things? And more importantly, unlike the Terminator movie, humans in the loop are a good thing. And that rise of the human now to be able to give us that final lift, which is system graph, you should learn from me and we can now do it even better. And this sets the table for where we're going in these applications. Now, these are examples from some of our joint customers. And what we see over on the left is taking a KYC or cross-sell churn avoidance, being able to increase the accuracy. Intervention of 10% is enormous. Now, no longer are we sending coupons to 1 million people. We're sending coupons to people we know have a high proclivity to react or are in an intervention loop. And Graham and Victor will talk more about that. In the patient and doctor world, how do we now sort of find where satisfaction and or bad care may be happening? How do we increase doctor using of better treatment plans, et cetera, doctor and patient 360, if you will, increase of 6%. These are, again, very, very large kinds of movements in the needle, if you will, and it's through this combination or recipe that we talk about. Now, everybody is used to what we call a node diagram, which is great. I see this connection of things. But now what we're able to do then is see what we didn't know, what we sometimes call a non-obvious relationship. The fact that certain factors, attributes, whatever they may be, may now show a human in the analytics part that, well, that is a bad thing if these 3 or 4 things occur. They are exactly the same in the positive. So if they're going in a positive direction, like a journey match, that we see here, now perhaps I want to find other similar, and again, Graham and Victor will tell us more about that, but now I want to do something positive. The second element then is when. When did it go wrong? Well, now we enter the concept of time. When and why did it go wrong? What were the things that led up to it? And now we can see things where up in the upper right-hand corner, we can see low sentiment score or other kinds of things, right? The other thing is where on the map. Right? Where did these things occur? There may be a correlation that also is linked with the time as well as those other factors. And what we're starting to see now is this in a normal SQL world is extremely cumbersome. It can be extremely slow and many times it's in arrears, but with a graph now it's more in 3 dimensions and it's in real time. And that brings us now to the idea of deep link analytics, which is why are things bad or good? What should I segment things as? How do I look for these non-obvious relationships? This now can be done at speed and in real time. And then finally, how do I find these patterns? And what if I do find these patterns? Are there flow charts or visualizations that mere mortals, if you will, can look at? right? It's the explainable AI or ML that these user interfaces, which is that third leg in the tripod, can really help us do, right? And then finally, it's the human. When I make a recommendation and I've done a deep link inside of a graph and I've done the right thing, it's the human that takes us the final mile that says, this was good, this was incredibly good, or in fact, this was not good, right? And it's that learning, it's that capability now for the graph and the system to get better over time as it gets more information. And that's really sort of that linchpin in the three of those. So with that, I'll jump in and I'll give a quick demonstration. In this demonstration, we're looking at a financial advisor, but not just a financial advisor. As Michael mentioned, the KYC, so know your customer's customer. In this type of an environment, what I see now is I have somebody who is a financial services person. They are recommending perhaps life insurance or annuities or other kinds of things. Well, there's two kinds or two layers. So the company has their own advisors that may actually work with me or you as the end customer, or they may work with other advisors that in effect work with their customers. So it's that KYC that's very important here. Now, I have the ability to do a couple of different elements. I can see this in what we call a dominant dimension of a product, or I can look at it in groups of people. In this case, what I'd like to do then is let's take a journey now on looking at a group of cohorts. And again, Graham will tell us more about what's behind the scenes. But in this case, I can start to see where those journeys fail. We're finding that certain kinds of things just aren't working very well. Certain kinds of things are working incredibly well, right? So finding where that problem is. And then I can see where the products and what those kinds of things are. And then how do I intervene in a positive way? Well, the other thing that I can do is let's pick on this group, the young and thrifty group. This is now a group that I want to learn more about. How do I do it better? Where are perhaps there are things that are broken that I want to intervene? And then more importantly, how do I segment and then go after those kinds of things? So what we see now is we don't see anything technically graphy yet. What we see now are filters and sliders over on the left, but these are hints into what's really going on behind the scenes. I can see influence, I can see sentiment, I can also see risk. And these are all things that are brought to you by graph behind the scenes. Now what we can do is start to break it down. We see that this young and thrifty group may have different kinds of disputes. They may have different categories of recommendations that may have gone well or done certain kinds of things. And now what I'm starting to do is I'm doing the analysis, that graph analytic that many times is very difficult. The other element here is to do this kind of analysis in the older world is typically cumbersome. It's a large 40 table join. It's very slow, and I can look in the rear view mirror. In this case, TigerGraph and specifically this kind of interface can be in real time. Now what I can do is dig in even deeper. Now I can see positive and negative journey paths, and I can filter those. I can filter those by product. I can filter those by patterns. I can do other kinds of things here. And then I can start to drill into how do I stop a bad pattern? How do I correct things that are going wrong, or even lean in even more? And as I sort of click on those different elements now, I'm brought to see what those different elements are, right? So what we want to do now is actually go even further. Now I can sort of get very prescriptive. What I can say is certain kinds of products, what are the paths that are best? Now I can actually make a corrective action. But again, behind the scenes, we're using the power of the connectivity to inform what these different sort of elements are. The other thing that I can do is segmentation. So now that I'm finding sort of where these things are going, and I'm looking for perhaps a high proclivity of things that I need to intervene with, now what I'd like to do is segment even further. And again, this is all sort of brought to us on the back end by the graph data source. And as I get into these kinds of things now, I can say, now I finally see my graph. Well, all of those other screens and connections were all in terms that I can understand. And understand sort of how to do that. Now what I'd like to do is actually find the similarity of customers, understand sort of what that abandonment risk or churn potential is, and now what I'd like to do is intervene, right? And so now I can run different kinds of marketing campaigns, those kinds of things to make a positive impression. So that's really what we wanted to do in this section, was sort of highlight a path. As we walk through that journey, put a face to what these things look like behind the scenes of a graph. And with that, I'll hand it over to you, Graham.
Thanks, Scott, and thanks for the awesome demo. I'm going to dive into the details behind the scenes a little bit. But before I do, I just wanted to mention this is what it looks like as you move down the path towards integrating graph, machine learning, and human-in-the-loop based systems in your organization. This is where everyone starts, is at the data cliff, where you're just assembling information and trying to get access to all your data sources. The intermediate stage, which is sort of market common for these use cases, is the implementation of business tools, BI tools, and gaining some visibility into what's going on in your data. But the ultimate end goal there on the right-hand side is to be able to augment your decisions using graph and machine learning, and then layering in that human-in-the-loop context that Scott just showed in the demo, to be able to ensure that your systems are running on the most accurate data with the most accurate domain expertise information it can be. So with that, let me step into a particular use case that is related to IDFA. So IDFA is a customer identifier that's used in the advertising and some other businesses. And whether or not you use IDFA in your business explicitly, the really interesting thing about using graph-based methods is that this is a solution to IDFA going away, as per Apple's announcement last year. The contextual information, behavioral information that you get with graph and then layering machine learning on top is the thing that allows you to build that context information. And this is the thing that allows you to represent your customer, not just by some random ID string, but by their behavioral characteristics. It allows you to understand who they are and why they're doing the things that they're doing. So to get that context, we have to get information into a graph structured format. And we use both graph and machine learning methods to do that. So let me walk you through here on the next slide how we get into the graph in the first place. So we use two different types of mastering of data, two different types of entity resolution and matching. And the first one here on the next slide is the use of machine learning based methodologies to understand which records in your data are the same, represent the same customer. And then the next slide is the addition of the graph-based methods. So what we do here, of course, is we match customers based on their associations to other customers, other products. Let's say if we know demographic information, addresses, those types of things. So those two methods that work in concert seamlessly allow you to build up rich representations of your customers inside of a graph database, which gives you that access in real time and at with a very powerful query language to understand who they are, and again, like what their behaviors are and who they interact with and why. Moving on into the application space and into the analytics here, which is the good stuff. This is the business changing stuff. We have the addition of graph-based machine learning methods. And before, I'm about to jump into two use cases here, as per Scott's demo earlier. But before I do, just at a high level, this is how all of this stuff works together. And if your eyes glaze over, bear with me for this one slide as I go through it. So we have on the right-hand side of the slide, the graph structured information, where all of the nodes here are things like customer and transaction and entity account, all those things. We extract a subgraph from that and we inject it into a graph-based machine learning algorithm. There are many of these things, and you can feel free to jump on our website if you're interested in the specifics. But as we perform that analysis, again in real time on your graph structured data, we output that information to the UIs that Scott just showed in his demo. So these are things like customer churn risk, could be intervention recommendations to avoid churn. It could be customer journey predictions and suggestions to help your customers out or to figure out cross sells or upsells. And you see a little bit, you just see a repeat of one of those screens in the lower right-hand side. So that's high level how it works. The next thing and final thing I want to talk about is as you're performing this, how do these systems in these couple use cases really work? And how do they surface themselves in the UI, which again, Scott just showed, but just to reiterate and make it crystal clear. So this is the customer journey use case. We'll be talking about how to understand who your customers are today, who they want to become tomorrow, and how to get them there based on the actions that they've taken previously. And we see a crystal clear representation of that here, where we have this sort of path through one interaction cycle with a company. And of course, you can take this cross-section sort of longitudinally to understand who those customers are, again, in long-term, short-term, to understand really quick intervention recommendations, or really long-term, of course, to understand how to help your customers migrate into the customer you want them to be and get them into the services and products that make them, that provide them the most value, to help them get to where they want to be. So how does this all work behind the scenes? Well, at a cartoon level of understanding here, what we do is we take a historical snapshot of what the customers have done. Again, showed you the graph data structure earlier. We extract, as I mentioned, the so-called subgraph, or sometimes ego graph, of our customer. And we do a predictive analysis on that subgraph to make a prediction or a recommendation about what will happen next in that customer journey. And as I'm showing on the next slide, we have a really detailed look about how this, I mean, this is as detailed as it gets. This is an output from TensorFlow. This is the real model operating on the back end. But you can see there on the left-hand side of the slide, the types of information that go into this system. And the type of output on the right-hand side is customer X will do this as a next step. And of course, we can roll that forward, that analysis forward in time, so that we know what that customer is going to do moving on and on and on into the future. And that's what we show here in the next slide, which is a snapshot of, on the left-hand side, who Fran Farmington is today as Fran relates to our financial services institution. In this case, it's a bank. And in this case, as you can see, that bank has helped Fran acquire some assets. They know something about Fran's credit score. In the future, of course, Fran Farmington would like to become a wealthier individual. Fran would like to have assets in various categories. And of course, the bank is interested in this as well, because long-term relationships are good for both the bank and for Fran. And as we just showed, we can use those relationships, those customer journey predictions, to actually guide, to make recommendations to financial advisors about how to help Fran get to where he wants to go. And again, that's that know your customer's customer. So what we have on the next slide is another use case related to customer cohort segmentation, which is exactly that behavioral, contextual based representation of customers that now all companies need to have in this sort of post IDFA era. This is how we, again, cartoon level, how we segment customers based on their characteristics. And the beauty is when you do this with TigerGraph in the background, what you get is not only clusters of customers, customer cohorts, that are represented by their characteristics, things like demographic information, locality, and then their individual transactions. You also get a much more rich representation because you know all of the other customers, all of the other products, all of the other situations that they've been involved with, and how those connections arise, which we're showing a snapshot of on the next slide. And this is pretty messy, and apologies for that, but this is how the sausage is made. This is the real representation here in a graph structure. This is a set of relationship metrics that we use to represent those customer behaviors. And this is, again, how we build those really rich representations of customers in context with their behaviors in order to make judgments and recommendations about things like customer churn, about things like predictive customer journey, and all of those various outputs that Scott showed in his demo. So again, to reiterate, let me just show a couple screens here. We have, again, a targeting mechanism that's based on the beneficial products in terms of cross-sell and upsell to customers and customer cohorts. Again, what's good for the customer is good for the bank or whatever financial services institution you're working in. And we do that by using the methods I showed above. A, understand the customer. B, understand who that customer is in context. And C, make recommendations to and about that customer. And the final screen I just wanted to show here on the next slide is exactly that. It's the customers in context. So this is how we visualize on a screen what the customers, what the groups of customers are, who they are associated with in other groups, what types of products are they associated with, and what recommendations do we have on those cohort and individual bases to be able to make, again, a successful customer journey, not only for the customer, but also for the business as well. So with that, I'm going to turn it over to Victor. Thanks.
Thank you, Graham. And thanks, Michael and Scott. So I'm going to talk a little bit more about the graph underneath, the graph engine and the graph database. So we can go on to the next slide. You've heard a lot about the why analysts believe graph is important. You've seen a lot of use cases for, financial and first of all, customer 360, knowing your customer better, and then how that is the starting point for getting a lot of beneficial gains. You've seen a lot of analytical techniques that can be done with graph. I'm going to talk a little bit about picking the right architecture and the right machine learning approaches so that you make a wise investment. Next slide. So first of all, scalability. If you're going to be doing customer 360, know your customer, whatever X360, bringing multiple collections of data together, you are going to be growing your data probably into a larger store than you previously have, or at least you probably have never had a graph this large. So first question, can your graph handle the size? So you need something that's scalable size. And for that, you want a distributed database. Distributed means that it is, there's a little figure down here showing like 5 databases alongside each other. We call that scaling out. So the thing is, the data is spread across the 5. You're not replicating the same data. That is a different type of scaling. That's to increase maybe how many queries you could run at the same time. But we're just saying you've got a lot of data. You're not going to put it all in one machine. You're going to put it in, spread it across 5 machines. And you want to be able to keep growing as your data expands. So you're going to want to look for a database that's distributed with auto partitioning to make it simple on you. And second, you want scalable performance, because it's not going to do you any good to just store more data if you still have the same amount of computational performance. It's just going to get slower because you've got like one CPU that's trying to work with 5 times as much data. You want to have, of course, more CPUs, and you want them to know how to work in parallel. That's actually not a given to know how to work in parallel. So again, you want to look for a graph database that is distributed and that has built-in parallel processing, hopefully massively parallel processing, so that the performance scales with the size. Next. Second, you're going to want real-time deep exploration because you're trying to get insight. You're trying to learn things from that data. Your data is large, and you don't want people to have to wait a long time. If you have those humans in the loop, you want their time is valuable. So when they ask a question, they want that response, and you're searching a lot of data. So first, you want to look for a native graph. That means, is this database designed as a graph database from the ground up? You will find some products that have a graph layer built on top of a different type of database. They may be built on top of a relational, on top of a key value. They may call themselves multimodal. If they're multimodal, you want to ask, what is your core type? All multimodals start as, well, I'm this type of database at the core, and then we sort of they've done real engineering, so it's not just a surface layer, but there's still one type that they're best at. And so, is that a graph? Probably not, but maybe you can ask. And the reason why is that if you need to traverse the graphs, a lot of those analytics that Graham talked about, you're going to be doing multiple hops. And to do those multiple hops efficiently, you need that native graph structure. You need those, adjacency-free indexing. You need following pointers, as opposed to doing table joins. If you're actually doing table joins underneath the hood, then it looks like a graph, but it's not going to perform like a graph. And secondly, you want to make sure that it offers real-time querying and updates. Is it an operational database? Because a lot of those analytics, you may think analytics is read-only, but first you may have real-time. If you're trying to do real-time recommendations for say a website, you're trying to follow along as the customer is exploring your website and give them new recommendations based on what they're doing. Or if you are doing something in the financial sector where people now do electronic transactions, that they are coming in thousands of transactions per second, micro trading, there's an incredible speed needed there. Even in more mundane things, just the expectation these days of having faster response. So you want to make sure that the database is operational and provides real-time updates. Next slide. Third, and this is the last of my points here, is you want to make sure that graph database is suitable for analytics and machine learning. So, the fact that Expero and TigerGraph have partnered together, we think we're a good fit, that we're a happy marriage in all of these points. So you've got a graph. Now what? Is this an appropriate graph for analytics and machine learning? So first of all, does it have graph algorithm support? Pretty much all the major graph databases out there have some sort of library. But one distinguishing feature is is the library open source, or are you 100% dependent on what the vendor has provided? Because say, Graham's thinking of, he's reading the research papers, or he's just thinking, hey, I've got a new idea. I want to use this algorithm. Is it available in the library? If it's not, what are his alternatives? Does he have to wait for the vendor to provide it? Or can he go in the query language and write one himself? So with TigerGraph, he can do that. He can just write the algorithm himself, because our query language, I've got a little sample of our actual code there. It's written in, it's both SQL-like at the core, but it has enhancements to make it very natural to implement algorithms. So it's developer and algorithm / analytics friendly. Some technical terms are, it's Turing complete, it's procedural, and it features control flow. So those are my 3 points: scalability, real time, and suitability for analytics and machine learning. So I'm gonna just got a couple more slides, and then we'll wrap up and take your questions. So this is just repeating one of the earlier slides of listing out some of the algorithms and some of the machine learning techniques that that might come into play, and you're gonna want to see, does your platform handle these efficiently? Next. Oops. All right. So I call this mapping out your road to success. You've gotten a lot of information today. And I want to suggest to you that it is possible to, have a fairly simple starting path. So first of all, we're here to suggest that you do some 360, customer 360. So you've got your multiple data sources. You're going to integrate them to build one graph. The first thing is to think about, how are you going to model that data? How are you going to connect entities from different sources, which actually turn out to be the same? And so, Expero's advisory services are a great idea there. on how to model your data. Then you're going to want to do some data preparation. You want to do some link analysis. Again, I already talked about merging entities. There may be some other enhancements you want to do to enrich your data. You have the raw data. Now that you have it, you can do some basic analysis to try to understand it a little bit better. And again, that can be either rule-based with rules that you've established, or you can apply machine learning to have the data, in a sense, reflect upon itself to discover things. And third, and that's really kind of as that was the core of what we discussed today. And then the whole world opens to you. We talked about some of these business applications, customer journey, product and service recommendation, marketing campaign effectiveness, customer satisfaction or intervention. All of these are enabled by just having that graph and establishing your analytical capabilities. So you can start with just one particular case and then build on. And next slide. So again, an advantage of using graph for your machine learning and AI is that it tends to be very explainable, because the graph data model, the connections have meaning to people, and a pattern in a graph can often be translated into an English sentence like, you know, this person bought this car from that dealership in that year using this sort of financing. That might translate into 4 nodes and 3 edges in the graph, but again, it can be translated easily into English. And when you build your machine learning based on these patterns, then your predictive models can be explained in terms of those in those ways, and that helps everybody. It helps the human analysts. It helps the business decision makers. It helps the customer themselves. You make a recommendation to the customer, and you can tell the customer why you've recommended that, and that gives them more trust in you. So next slide. And again, here is another way of modeling how you could construct your system. And this is a nice thing that you can do with TigerGraph and with an Expero. You could do sort of single point, one point, everything in the database, or you could export it. The pipeline I showed previously, you're computing features in the graph, and then you export the data to do machine learning in some other specialized platform, which is fine. Another option you have is in database machine learning. So you build your graph, you enrich the data, and then you apply some of these analytical techniques right in place. The advantage is you don't have to export the data. It's always up to date. So you only have to maintain one system. We already talked about it can be scalable. The G-SQL language supports this type of analytical and algorithmic work. And then you don't have to export the data to deploy your model. It was trained in the graph, and you can deploy the model right in there in the graph. Okay, so I'm wrapping up here. Again, just to reiterate some of those points I made before about trying to pick the right graph database. You want to make sure it has that real-time deep link querying capability, which is going to help you find those hard to find patterns and perform operationally. You want one that scales with your needs, so you can integrate all your data and it's elastic to grow as your needs grow. And you want the query language and the engine support to do that in database analytics and machine learning. And using a nice interactive dashboard, you don't need to be a developer to do really sophisticated and highly valuable things. So thank you. I think we've tried to connect it all. We try to tell you how, Customer 360 is going to make your data more visible, more accessible and extensible. Do some entity resolution, which is seeing which entities in the graph are actually related or the same and joining them. So that's discovering new truths. And this becomes the launching pad for a whole host of essential business applications. And I want to thank you for your time. You can try TigerGraph for free on the cloud. You can contact Expero to get one of their demos. We've got demos. Both of us are here to answer your questions. I want to, again, thank you for your time.
Yeah, thank you all so much for the presentations today. We did have a few questions that came through during the presentation, so I want to go ahead and get to those. But I did just want to mention to everyone on the call right now that if you had any additional questions, you can drop them in the Q&A box or the chat, and we'll be sure to answer them for you. Okay, let's see. So the first one that came through was, I think this one's for Graham. How much customer data would I need to see correlations in the graph?
Interesting. So typically what you're interested in is not just volume of data, but the interconnectedness of that data. So volume can be quite small and you could have highly connected data. The best way to know whether or not you have that type of information is just to dig into the data a little bit and see if you can connect those entities with edges, and we'd be happy to help you out with that. So feel free to reach out.
Great, thank you so much, Graham. It looks like another one came in. Victor, this may be for you. What types of algorithms come in TigerGraph that would facilitate 360 analytics?
Sure. First thing that comes to mind are similarity algorithms like Jacquard similarity or cosine similarity, because for entity resolution, what you're essentially trying to answer is, are these two things in fact the same person or same business, something like that? And similarity algorithms naturally answer that question. You might also look at maybe some community detection to see if they're surrounded by the same community. You could, so those are the first things that come to mind, but there are lots of other algorithms that might be valuable. A more advanced machine learning related technique, graph embedding, is a cool option that has multiple benefits and could also help you with that.
Great, thank you so much, Victor. And Scott, it looks like we had one for you as well. How long and what would we need for a POC?
Well, as Graham mentioned, it all starts with the data. As Michael mentioned, it starts with a use case. With those two things, we can basically begin to get started. There are sort of two flavors, if you will. There is the way that Victor mentioned out online, where you can sort of self-start with the TigerGraph Cloud. The second version is get in touch with us, and at no charge, we can sort of give you a roadmap that, you know, sort of Victor laid out a little bit of where we can sort of give you a plan. And should it all look good, we run rapid versions of these in days or weeks, kind of depending on how much data you have and how big your use case is. Really, it's just those two things to get started.
Okay, great. Looks like we have time for one more that came through. Michael, I think this one might be for you, but what types of TigerGraph features make it better than SQL or BI tools for 360?
Well, those serve different purposes. And so, you know, we have 40 years of tradition behind us on transactional use cases that are really about SQL databases. SQL is amazing. We actually leveraged it to build our own language, GSQL, Graph Structured Query Language. Nothing wrong with SQL. We made it more powerful for connected data. And so really, it's not a question of, are we better than a relational database, or, you know, is GSQL better than SQL? It's about how you're using that to what outcome. And the summary is that if you're focused on connected data and you're looking to understand the relationships that guide that data, then you really want to take a look at graph plus machine learning in this context. So the advantages are, you know, better semantics for understanding connected data, more powerful graph algorithms. And then finally, I think that, you know, the ability to integrate multiple data sources, external and internal, structured or unstructured, is much more powerful in a graph database than in other formats. So summary is, both SQL and GSQL and other languages are very powerful, but the difference is what impact they have in driving a customer 360 use case that you can't do with previous technologies. So we're excited that we can help customers learn more about their customers using GSQL, and we are going to be complementary to all of your existing systems and data sources, and we look forward to working with you on all that.
Great. Well, thank you all again so much for your presentations today. I really enjoyed them. And just as a reminder, I'll send out the recording later this week. With that, we'll go ahead and end today's webinar. I hope you all have a great afternoon.